Hi students, welcome to Alpha C Learning Program Maths class. Now in previous session students we have observed about concept of number of normals. Okay, in that concept we have observed g square plus here again 4h cube. G square plus 4h cube, if you rearrange, that means just by taking minus common from here. Okay, in g square plus 4h cube we have taken 2a minus x. Just I took minus common, then this is a curve exactly in this way. Okay, so this is the curve, nothing but s equal to 27ay square minus 4 into x minus 2a whole cube, whatever yesterday we have derived because of the concept of normals. Okay, now if you take y value 0, this is 2a comma 0, which is exactly on axis of the parabola, that is on x axis. And now here to this parabola, whatever the concept we have derived, that is exclusively to the parabola y square equal to 4ax, right? And here this value you students observe 2a comma 0 is exactly this point. Now whenever s11, that means a point x1 comma y1, a point x1 comma y1, if it is inside the curve s is 0, the concept we know it is s11 less than 0, that is inside. Now we observed yesterday when x1 is more than 2a, or this g square plus 4h cube value we have observed less than 0, then what is the observation? 3 normals can be obtained. And you can remember directly in this way instead of taking g square plus 4h cube. So if you take this one, then s11 less than 0, 3 normals can be drawn to the parabola y square is 4ax from a point x1 y1, that is our suffix here 1 1. And exactly the point x1 y1 is here on the curve, anywhere on the curve. Exactly the point x1 y1 is exactly here on the curve. Then you can get how much here? s11 is equal to 0. That implies 2 normals can be drawn. That implies in the 3 normals 2 are coinciding, one is different, right? And next one, if it is x1 less than 2a, that means if it is s11 greater than 0, completely outside. Okay, this is inside the curve and this is outside the curve, completely outside. If you got s11 is greater than 0, then there exists one and only one normal. So x1 y1 can be anywhere this side, then we can say here it is one normal. Now in this case students, here these model problems whenever you come across, directly make use of this. At the same time, suppose this x1 y1 is exactly on axis of the parabola. Okay, on the axis y square equal to 4ax. On axis means in x1 y1 what will happen? y1 is equal to 0. When y1 is 0, now the case becomes only for x1. That means this entire value is now 0, only this case. Therefore, if you use again same concept now, you will get exactly, suppose x1 is greater than 2a. That means when the point is exactly on axis of parabola, then y1 is 0, our concentration is only on abscissa. If x1 greater than 2a, 3 normals, equal to 2a, 2 normals, and less than 2a, only 1 normal. Because of what reason here? This is 0, minus of the value is less than 0 implies plus value is x minus 2a greater than 0. Okay, so you got here minus 4 into x minus 2a whole cube, this is less than 0. That implies x minus 2a whole cube value is greater than 0. That implies x is greater than how much here? 2a. Okay, therefore whenever the point is exactly on axis of parabola, concentration has to be only on the abscissa. If it is more than 2a, 3 normals, equal to 2a, 2 normals, less than 2a, exactly 1 normal. And suppose let us consider here one of the examples. Find number of normals that are passing through 2 comma 0 to the parabola y square equal to 16x. Okay, they are asking here passing through 2 comma 0. That means in place of x1 comma y1, here you are having how much? The point is nothing but 2 comma 0. So this is our x1 y1. And in this problem, what is our x1? It is 2. Moreover, point is on exactly axis of parabola. Then what is this value here? 4a. 4a equal to 16 implies 2a equal to here 8. Then what is the relation between x1 and 2a? Okay, so here 2 value it is less than 8. As 2 is less than 8, the meaning is here x1 value is less than how much here? 2a, implies the conclusion is what here? There exists one and only one normal. Okay, so here the conclusion is there exists only one normal to this parabola drawn from the point 2, 0. And next one, if three distinct normals, already they are telling three distinct normals are drawn to the parabola y square is x from the point c, 0, then what is the range of c? Okay, already they mentioned three distinct normals. Then what is our condition? Here again the point is on axis of parabola, and here the 4a value equal to how much? 1, so that 2a equal to exactly 1 by 2. Now what about three distinct normal means x1 is greater than 2a. Therefore here in place of x1 we are having how much here? C. So this is our x1 value and that is nothing but c value here. Therefore we can say c must be, that is x1 has to be here greater than 2a for three normals. Okay, for three normals this is the condition, and if you substitute c must be greater than how much here? 1 divided by 2. Okay, so this is x1 value c and this value is here how much? 2a means 1 by 2. Okay, that implies when c is greater than 1 by 2 or 1 by 2 to infinity for c values, then we can say there exist here three normals. Okay. Now observe students, one more problem. When the equation is not exactly the standard form, that is number of again same type of percent distinct normals drawn from a point -2, 1. Okay, -2, 1 to the parabola like this. If it is given again number of normals question, then just let us make use of here again the translation of axis. Okay, so what about here equation? First let us convert in the form of here the standard equation y square minus 2y, and next the other value you can send that side, it will become 4x plus 3. Then if you add here 1 both the sides, then we will get y minus 1 whole square is equal to 4 into x plus 1 by adding here how much? 1, right? And now this is the standard form, that implies here this equation is y square is equal to 4x. Okay, now you got here the equation exactly in our standard form where capital X is equal to how much here? X plus 1. Okay, now in the same way what about this coordinate? It is the old system you are taking, that is x1 y1. Then I am using this one here. If I write in this way -2 plus 1, the given point, okay, then it is equal to how much? -1. And in the same way y is equal to how much here? It is y minus 1. Okay, y minus 1. Again same point if you substitute here also, then it is 1 minus 1, so 0. Therefore now what is the question? Completely changed. That means number of, okay, number of distinct normals. Number of distinct normals that can be drawn from which point here? From the point. What about the value you got here? X, y, that is -1, 0. From -1, 0 to the parabola y square equal to 4x. Okay, just whatever we have done in the previous one, in the same way here moreover observe the point is on where here? It is on axis of parabola, right? And here the value x1 you got -1, and here 2a equal to how much? This value it is 2. Therefore x1 y1 this value, and 4a is 4 here, therefore 2a equal to how much here? It is nothing but 2. Okay, now what is the relation between x1 and this 2a? x1 is here this value -1 and it is 2, implies you got -1 obviously how much? Less than 2. That implies you got here the conclusion as x1 is less than 2a. Okay, so whenever we got x1 is less than 2a, then our result is nothing but what here? Number of normals, it is one and only one. Okay, so here just the total problem we made use of the concept of translation of axis, as this is the equation of parabola. Point also we converted in terms of new coordinates x comma y, and this is the point -1 0, and the parabola is y square equal to 4x. Thereby again same concept we observed, the point is on axis of parabola. So x1 value if you take, it is less than 2a. So -1, this is 2 less than. Therefore here the conclusion is number of normals is nothing but 1 and only 1. Okay. Now what about here this problem? Observe students, this problem also let us make use of the same thing, but here they are asking about already normals number given, that is 3 distinct normals they are drawing from a point h comma k to this parabola. Then they are asking about what is the greatest value of h, greatest value in the sense integer, okay, greatest integer value of x. So this is our question. Okay. So already given what here, 3 distinct normals are drawing to this kind of parabola. Then how we can evaluate? In the same way we proceed. Okay. That implies here, let us consider again the standard form. What is our standard form here? That is y square minus 4y. Okay. And this side if I write, it is minus 6x minus 10. Y square minus 4y is minus 6x minus 10. Now how much to be added here? 4 we need to add, and thereby you got here y square minus 4y plus 4 is equal to minus 6x minus 6. We added 4. Then let us take here, this is y minus 2 whole square, and here we need to take minus common. Thereby you got here minus 6 into x plus 1. Okay. Now once you got the way in this, the problem in this way, then the question is already which value they gave here? Number of normals already given. Those are how many here? 3. Now what about the standard form if you are observing? The standard form we got y square equal to, okay, the standard form you got y square is equal to minus 6x, right? So this is the standard form we got. Once students you got this kind of standard form, then this value whatever we have taken for y square is 4ax, you know the parabola y square is minus 4ax, the relation is nothing but both are images of one another with respect to y axis. Okay, then exactly the same concept, you just take the diagram in this way, because these two are, one is image of the other with respect to y axis. So exactly the diagram is coming in this way. Now here 2a comma 0 means here it is minus 2a comma 0, and this part is falling again here inside, and this one is here outside. So what is our result when x1 is less than? That means here s11 less than 0. That implies if the point is again on axis, then x1 is less than, this side it is coming minus 2a, and again these other values we can simply make use of the same concept. Okay. Then how we can write this one? So y square is minus 6x students. Then what about here capital X value, where capital X is nothing but x plus 1, and capital Y equal to how much here? It is nothing but y minus 2. Okay. And now what about here our 4a value? 4a is equal to how much? It is minus 6. So 2a is equal to what? The value is minus 3. So in place of h here you are having which value? It is x plus 1. From a point, suppose you take the value is nothing but here this is h comma k they are asking. Now we consider as they are asking about greatest value. Okay, for greatest value you have to consider here the point must be on axis, because if it is falling exactly on axis, then you can find here greatest value of this number. Okay, so for maximum thing we are taking here the point has to be on axis, then you can avail here the greatest value. So h comma k is on axis we are taking. When it is on axis, actually what about our condition? Okay, now here you are using transformation of axis. Then we consider here h value is less than 2a, and now here in this way if you write the value, it is nothing but h is less than minus 3. But they are asking about here the maximum value. So maximum integer means, what is the maximum integer we can write? The maximum integer is nothing but minus 4. So minus 4 is the maximum integer, such that here the point is actually here from the point hk there exist how many normals? 3 normals. So the concept is nothing but exactly you are taking the entire thing this side. Okay, next. Now let's observe students this problem. Find number of normals drawn from the point 3, 4 to the parabola x square is 8y. So far we have observed according as the standard form y square is 4ax, and if not exactly we have taken the image concept, therefore we observed y square is minus 4ax also. Now this one is nothing but here with respect to the parabola x square equal to 8y. Okay, now here as far as we require about the number, moreover we know these two types of parabolas are images of one another with respect to a line y equal to x. Therefore same problem you can convert as exactly in this way. It is the same as find number of normals that are drawn from 4, 3. Okay, with respect to this is y square equal to 80x. Both the problems are here one at the same. Okay, na? Because of the reason that the point, that means these two curves are images of one another with respect to y equal to x. Moreover, we are not requiring here equations, but our requirement is just number of normals. Okay, thereby simply you can make use of this condition. Then to make use of this condition, again students observe so far whatever problems we have done, those are directly from where we have taken exactly when the point is on axis. Simply we said x1 greater than 2a less than 2a etc. Whereas here it is not the case. The point is not on axis. 3 is there. It is not 0. Okay. 3 is there here, and hence what we want to do is the same problem. You can make use of this kind of relation. Okay. That implies S11 we find here, and when S11 less than 0, greater than 0 etc. Observe clearly the point is here not on axis of parabola. Whenever it is not on axis of parabola, we are going through this kind of formula. Okay. So let us find here what is that S11. So first of all, yes, you know students, all of you, this one we require now which kind of point? x1 comma y1 is here 4 comma 3. So this is our x1 y1, and in place of a you are having 4a equal to how much here? 8. That implies a is equal to here 2. Okay, a value is 2. Now I am writing here s value, that is 27a y square and minus 4 into x minus 2a whole cube. Now our interest is with this point 4 comma 3. Therefore S11, this is nothing but 27 into a means 2, y square means 9, minus 4 into x means it is 4. Okay, minus 2a means it is 4 whole cube. That implies you got this value is 0 completely, and this one is which kind of value? Positive. So you got S11 value greater than 0. When S11 is greater than 0, how many normals can be drawn? One and only one normal can be drawn. Therefore here the conclusion is nothing but how much here? Only one normal can be drawn. So what is our observation students in this problem? Whenever they give this kind of standard form, and moreover they are asking only number of normals, simply we have changed the complete concept like this. Okay, and thereby you can decide the answer as how much here? One and only one normal, right? Now let us observe the another concept students, that is nothing but shortest distance between two curves. The two curves may be two parabolas, or they may be one parabola, one circle, etc. Now the concept is shortest distance between. Okay. Now to observe before going to this one, shortest distance between two curves, first of all observe the given two curves nature. How are the two curves given in the problem? So this is very important. The observation is if at all they intersect one another. Okay, if they intersect one another, then obviously the shortest distance is nothing but 0. Therefore, whenever they want to give this kind of concept here, the two curves they do not intersect like this if they are coming. Then what about here? Shortest distance. Now all of you clearly you can observe just from the diagram itself, shortest distance implies here wherever the two tangents, if you take here, this is one tangent and this is another tangent. If this distance is minimum, okay, distance between the parallel tangents is minimum, then we can say that is nothing but shortest distance between the two curves. Suppose you take one is a circle here and this one is a parabola, okay, then again we want shortest distance between these two, circle and parabola. Then again we want to take here the help of tangent. So this is the tangent drawn and this one is the tangent drawn to this one. Then this distance is exactly the shortest distance between circle and parabola. So whenever they ask a concept of shortest distance between two curves, then they give definitely they do not intersect each other. If at all they intersect or if they touch each other, obviously the shortest distance is nothing but 0. Okay. Therefore here first of all we have to observe how are the two curves. Now first curve, let us observe students here. Whatever x and y terms are there, here those terms only just interchanged. Okay. So if you observe two curves here, if you interchange x and y, it is nothing but the other curve. So if at all in this way any problem exists, immediately you can understand these two curves are images of one another with respect to the line y equal to x. Sometimes they give exactly with y is minus x. That means here 2y square 2x minus 1. Then they may give here exactly minus 2y minus 1. Then you can understand those are images of one another with respect to y equal to minus x. So this is just mere using our observation. Okay. So now what about the process then? Let us observe here. First of all, let us write here the two curves are, okay, the two curves are images of one another. Two curves are images of one another with respect to what here? Images of one another with respect to y equal to line x. Okay, so y equal to x line. So with respect to that line, these two are images of one another. And what is this equation here? Y square equal to x minus half. And again this equation if you observe, x square equal to y minus half, right? So these are our two curves. Now what about the diagram? Suppose if you consider this is origin, here half, that means 1 by 2 comma 0 is the vertex. Therefore this is the curve you can take. It is 1 by 2 comma 0. And what about here? This is 0 comma 1 by 2. The other one is nothing but 0 comma 1 by 2. So this is our curve. It is nothing but here 0 1 by 2. And now they are asking about shortest distance. And clearly you can observe here the line is y equal to x. So this is the line y equal to x. Okay. Now whatever the tangents for shortest distance, if I take a tangent here, definitely it won't be shortest. Now the shortest is obviously which are exactly parallel to the line y equal to x. Okay. Those are exactly parallel to the line y equal to x. Therefore clear observation is nothing but here as the slope of this line is 1. Therefore slope of tangent is 1 here as well as here also for the concept of shortest distance. Okay. Therefore what we write here, for shortest distance slopes of tangents, okay, slopes of tangents to the two curves, okay, to the two curves must be how much here? To two curves must be, what is the value here? It is 1. Slope of tangents to two curves must be 1 because they are parallel to which value here? It is y equal to x. Okay, must be 1. Now just to use here any concept for slope, you can use this one, that is transformation of axis or directly differentiation, but differentiation concept is a very lengthy, it won't take that much length time. Therefore you can make use of simply the differentiation concept. Instead of using 80 square plus 280, again you have to add half comma 0 etc. Better this one, it will take very less time. So I am using this one. Now it is 2y dy by dx equal to how much? 1. Just I want to make use of here the slope value 1. So dy by dx at a particular point. At a particular point means suppose you take this is x1 comma y1. Okay. To this we are differentiating. So at a particular point if I take x1 y1, then now I want to find here that is dy by dx at x1 comma y1. Understand, this is equal to how much? 1 divided by 2y1. Okay. Now, but what is this value here? Exactly at this stage the slope is 1. Exactly at x1 y1. Therefore, 1 is equal to how much here? 1 by 2y1. Hence, y1 is how much now? It is 1 by 2. As y1 is 1 by 2, then immediately what about here? X value. Okay, from the curve. Therefore, we consider from the curve y square equal to x minus 1 by 2. Now, our requirement is x value. So, this is 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2 means 3 by 4. Therefore, x is equal to now how much? 3 by 4. So, that students you got now the value how much here? 3 by 4 comma 1 by 2. Therefore, x1 y1 is nothing but here 3 by 4 1 by 2. Now, same process I am not going to use the another curve. Because of what reason? Every time just take the advantage of the line y equal to x. What is the advantage of line? If you take the value x1 y1, the image with respect to this line is how much? y1 comma x1. Why we are calling here image? Because at this stage exactly these two are parallel. Moreover, it is exactly which kind of distance? Perpendicular, right? Therefore, this point is how much now you can take? It is 1 by 2 comma 3 by 4. So, if it is A, then this is B. Now, we require just what is the distance between A and B. That's it. Okay. So, the shortest distance is nothing but distance between A and B. And this point you got because of the concept that image of the point x1 comma y1 with respect to the line x minus y equal to 0 is nothing but y1 comma x1. So, with that knowledge you got this value how much here? 1 by 2 comma 3 by 4. Therefore, the shortest distance is AB. Okay, so this is our shortest distance. AB equal to just ordinary distance formula, or you can use perpendicular distance from this line onto this. Anyways, you can find here. So, 3 by 4 minus 1 by 2 whole square and plus it is 1 by 2 minus 3 by 4 whole square. So, if you take square root, this is our value. So, if you simplify, what would be the answer here? 3/4 minus half means it is nothing but 1/4, right? 1/4 you are getting whole square. So, 2 times if you take, then you can get final answer. So, students, this is the procedure of finding shortest distance between two curves. And first observation must be here, are they images of one another with respect to a given line? So, here clear observation is y equal to x, and thereby we found here slope of this line is 1. Hence, here at the same stage wherever shortest distance is requirement, there actually these two tangents and along with this one they are parallel. As they are parallel, here slopes are equal. Therefore, we found using here dy by dx concept. Okay, and next you got here slope is 1 by 2 by 1, and that is 1 because of the reason it is equal to what? Y equal to x slope. So that you got this is 1. Okay, and now from this one we substituted y1 is 1 by 2 substituted here, and x1 you got 3 by 4. If at all you have any doubt, just substitute here 3 by 4 minus 1 by 2, that is nothing but 1 by 4, and here also 1 by 4. So this is the procedure, students, to obtain here shortest distance between two curves. Now let us observe again the same question they may ask in other way, that is find minimum area of circle which touches both the parabolas. Okay, what is the minimum area? The previous problem directly they have asked you about what is the shortest distance between the two curves, but now the same question, the only here way of asking is different, that is find minimum area of circle which touches both the parabolas. Again, students, observe what is the relation between the two curves. Y square here, x square minus 4x here, in place of x exactly you are getting y here, and minus 8y here, y place you got exactly x here. Of course, constant in both the equations, it is the same thing. Okay, That means clearly you can observe in this problem also we can say the two parabolas are images of one another with respect to the line y equal to x. Okay, then how to do? That means if one parabola you got like this and another parabola is in this way, then they are asking what is the minimum area of circle which can touch here both the curves. That means if I consider like this one is the circle which can touch here both the curves. Okay, so this one is the minimum area. That implies what is the again the same concept, just find here the shortest distance. Okay, the shortest distance, and that shortest distance is nothing but what here, the diameter of the circle. Okay, the diameter. So whatever shortest distance, that is nothing but here diameter of circle, which is nothing but 2r, and from that shortest distance get the value of r, then area, that is minimum area of circle, is equal to what is our formula, pi r square. So simply you can make use of this concept just by finding here shortest distance. So what about here again shortest distance? You observe the concept, everything, that is nothing but what here, y equal to x, line slope is here how much, 1. Okay, so slope of y equal to x equal to 1, this is 1, and which is same as what actually slope of tangent to which one here, tangent to both the curves. Okay, so both the curves at particular point, to both curves at particular point, and what is the particular point where we are going to obtain the shortest distance. Okay, suppose let us take this is A and this is B, and at the points which one here, A comma B. Okay, at those points, then you can make use of again dy by dx concept here. So this is already 1, so if I write dy by dx concept, this is 2y dy by dx, and minus 4 here, this is minus 8 times dy by dx plus 40 is equal to 0. Now our interest is what here, y coordinate or x coordinate. So dy by dx wherever it is coming, substitute the slope value as here 1. So 2y minus this is 4 and minus 8 plus 40 equal to 0. That implies 2y is nothing but this is 40 minus 12, this is 12, and therefore 28, and hence what is our value, this y is equal to how much we got, 14. Right. So now students, we have observed 2y into dy by dx. Okay, minus 4 minus 8 dy by dx, sorry this 40 is not there. Okay, so this one we are eliminating because differentiation we have done, this is equal to 0, and that implies you got how much here, the value you got 2y minus this is 12 is equal to 0. So y is equal to 12 by 2, that implies 6. Okay, so once you got y equal to 6, then substitute here so that you can obtain clearly x value. Therefore for x, if I am substituting here 36 minus 4x minus 8 into 6, that is 48, and plus 40 equal to 0. This we substituted from where actually from curve. Okay, from the curve, wherever you started the differentiation, from the curve if you consider, you are going to get this one. Then what is the value you can obtain here? This one is 4x is equal to, if you send this value the other side, then this value is here minus 8, and 36 minus 8 means the value is 28, and hence x is equal to how much here, 7. Therefore coordinates you got, one coordinate you got how much here, 7 comma 6. Then obviously what about the other coordinate, it is nothing but 6 comma 7. So here if you got this value as 7 comma 6, now this is nothing but how much you got, 6 comma 7. Okay, so students, you got here these 2 points and find distance between them, that is nothing but here 2r, then the minimum area is nothing but how much, pi r square. Okay.